Hi, and welcome back to Solving Quadratic Equations by Factoring. All right, in this video, we're going to look at how to factor two perfect squares. Well, how do we know that two factors are perfect squares? Well, first of all, what we should do is we look at our first and third terms. So I'm going to look at the first term and the third term in a trinomial. So it's the first term and the last term. And just like when we use the shortcut method, if I go ahead and factor it, so let's look at the first example. In the first example, I have x squared plus 2x plus 1. Well, if I factor the first and third terms, just like I do in the shortcut method, I get x and 1 and 1. Well, I can see that whatever the square root of the first term is, it's basically the same number, which makes that first term a perfect square. And then if I look at the second term, when I find the two factors, the factors are also the same number, which makes that term a perfect square. Well, if that's true, and I have a term in the middle, which is 2x, well, if I look at the product of the square root, so that would be one term each. So for instance, the product of 1 times x times 2, then basically whatever the square root of the first and the third term are, then I multiply by 2, that gives me 2x, then it should be the middle term. So basically the middle term is double whatever the square root of the product, so the multiplication of the first term and the third term. I know it's a little bit to process, but just think about it for a second. If you look at x squared and 1, or in this case, a squared and b squared, then if you take the square root of each of them, the square root of a squared and the square root of b squared, you get a and b. So multiply a times b and then multiply that by 2, and then that should be your middle term. So here, the square root of x squared is x, the square root of 1 is 1, 1 times x, and then times 2 would give me 2x. Okay, so that's how you recognize a perfect square. And sometimes you may recognize it, and sometimes you may not. But it's okay. You can still use shortcuts method, or you can still use the factoring by grouping. But since we recognize that it is here, I know that each of my terms, when I put them into brackets, will be x and x, of course, and then I'm going to have a 1 in each term. So both of those are addition, so I'm going to add them up. Because my rule says that if this is the case, if I take the square root of the first and the last term and I double it and it gives me the middle term, then it's a perfect square. And if it's a perfect square, it takes this form. Basically, both factors are the same. So we kind of saw that in the problem above, but here's just another chance to process that and actually see that there's actually a shorter way to do this if we can recognize relationships early. So in this case, I set my factors equal to 0. X plus 1 is equal to 0. X plus 1 is equal to 0. And so x is equal to -1 and x is equal to -1. So this is what we call a double root. So that's why when we take the square root, the product of the square root of each, the first and the last term, and then double it, then we get a double root. And so it actually ends up being the same number. And so this one touches the graph as we looked at. Okay, let's look at example 2. Here's another example. Let's look at 4x squared. So that's going to break down into 2x and 2x. Remember, it has to be perfect square. And this one is 3 and 3. So if I take 2x times 3, okay, so the square root of each term, or the product of it, and then times it by 2, which is what I'm supposed to do with the middle, I get 6x times 2, which gives me 12x. Okay, so that's exactly what I wanted in the middle. But notice here I have a minus sign, and this is a positive sign. Well, that means that I'm just going to have two of my factors are going to deal with differences. Okay, so basically I have my brackets, and in each bracket I have 2x and 2x, and then I have 3 and 3. And so in this case, they both will be subtraction. Okay, so 2x minus 3 is equal to 0, and 2x minus 3 is equal to 0. And of course, if we check the outside and inside terms as we've been doing, that would be a negative 6x. And of course, this one would also be a negative 6x. And when I add those together, it will give me that negative 12x there. So now let's just set them equal to 0. 2x minus 3 is equal to 0. And then 2x minus 3 again is equal to 0. Well, 2x is equal to 3, and 2x is equal to 3. Therefore, x is equal to 3 over 2. And of course, x is equal to 3 over 2. So it looks like my answer to as a solution where the graph crosses the x-axis is 1.5 or 3/2. All right, I hope this video has been helpful, especially in looking at a shorter way to solve when we recognize the relationship of a perfect square. So this one, of course, is perfect squares, not to be confused with difference of squares, because we have all of our terms here, and they both meet the conditions of a double root. All right, thank you.